So exercise 134, question number 6. Similar sort of method to question number 1 that we went through, but now we have 3 forces that we need to find the resultant of. But the procedure is the same idea. We've got F1, F2 and F3. We've got 3 forces. We find the vertical components of each of the 3 forces and add them together, and the horizontal components of the 3 forces and add them together. We've got to be a little bit careful though, because we need to think about direction of these forces. So if we consider a point, we would consider maybe by convention that forces to the right would be positive, forces to the left would be negative. So we can see in this particular case that all of these 3 forces, the horizontal components of F1, F2 and F3, all act to the right, so they're all positive. However, if we look at the vertical components of the forces, then we can set our convention. We can either set up as positive or up as negative. It's up to us. But one's going to be positive, one's going to be negative, which means that when we look at the forces again, F1 is going to be positive, the vertical component. F3 is going to be negative. And in this particular case, F2, the vertical component, is going to be 0. So we've got to make sure we take into account signs when we do it. So have a go at this question. Find the total vertical component of the 3 forces, the total horizontal component of the 3 forces, and then use Pythagoras to work out the resultant and its angle relative to the 5 Newton force. So you're going to end up with a right angle triangle where the horizontal component is going to be an addition of F1, F2 and F3, and the vertical component, and I've guessed it's going to be positive but it might not be, is going to be a combination of F1 and F3 because F2 is 0. And then when we've done that, we find the value of the resultant and its angle. Have a look at the solution to question number 1 if you've not done so already, and then try this out and see if you get the answer in the textbook.